Good morning, students. Welcome to Bombay Academy's videos. So the today's lecture is related to corporate finance. People who are into finance sector, they will constantly be given proposals for a project which they need to analyze the returns before making the decisions to whether to invest in such a project or not. So it's like you make the initial investment, and from the first year onwards the project will begin to give you payoffs. So this thing can easily be done uh, with Excel. Before doing it with Java, I will show you a Excel prototype, how this can be modeled with Excel, and then I will show you in Java. So it's this pre-calculated data set. You have how much investments you will make in the project. These are the inputs, these 5 values, the how much investment we are going to make in it, and from the year 1 how much income you will get from the project, and from year 2 onwards there is increment, how much extra money the project will generate. The lifetime of the project is the project duration. So how much is the discount rate? It's like the risk adjusted returns that you expect from the project. So with these inputs we are going to calculate the net present value of the project. So sorry, we will make this as okay, first time I am putting minus sign in the front because it is a cash outflow. Here onwards you will put positive sign because we are making money from the project. So every year the project will give 1000 extra up until the end of 4th year. Okay, now I am going to give the NPV formula. It's built in the Excel, Calc in Linux, LibreOffice. So the risk adjusted discount rate is the first argument, and the series of cash flows that the project gives you. You need to put the initial cash investment outside the function call. So it's the formula is this NPV of discount rate comma the cash inflows plus cash outflow. So you are getting 2000 rupees as the net present value. So this same thing so this is the formula that we are going to use here. So let's start doing it in Java. the prompt strings in one array. Now we will take so this is you are creating a new reader that will get its input from the standard input. So okay, we are assigning it to an array of floats. So D is the incremental cash flow that you collect every year. The beginning we will assign the negative amount of our cash flow as the initial value, NPV's initial value. This is a simple arithmetic progression. Okay, good. Our compilation is done successfully. Let us this is the same thing that we saw in the Excel sheet. I'm entering it here. Okay, index out of bounds exception at line number 21. Okay, this matches with the value we have calculated here. Now we will go to the second part of the assignment, which is calculating the internal rate of returns. Internal rate of returns is the risk adjusted return that gives you 0 NPV for the given project cash inflows and given project duration. So I will make a new project. Almost the first part is remains the same. So we will not take rate of return from the user. That is what we are going to find out here. So I will remove that part. Or to begin with, I will assume it to be 0.18 we calculated. This we are going to adjust to find the new R. So now NPV, we are going to get a step. You know, the step, if NPV is less than 0, the step will be minus 0.01. Otherwise it will be plus 0.01, because if NPV is 0, then we know that the assumed rate of return is on the higher side and we need to keep decrementing it. So I will take last NPV equal to 0, and what I am going to do is I will compare the previous NPV and this NPV, and if there is a change in the sign, then it means we have reached the 0, the returns that gives you 0 NPV. So I am going to use XR of the two numbers. XR of two numbers is positive, means the two numbers are of the same signature. So that is the logic I am using here. I think the greater symbol has higher priority than XR symbol, so I am using extra parents. So you keep adjusting the rate with the step. Last NPV, you put the recently calculated NPV into last NPV and calculate the new returns. Okay, so this loop will run as long as both the last NPV and the new NPV are of same sign, but when one of them changes switches the sign, then it will come out of the loop. So now our IRR equal to you need to take the lesser of one of the NPVs, the rate that whose value is close to 0. So if NPV is greater, take R minus step, or if last NPV is greater, take R. Okay, so we have completed the first step. Let us run it. I am giving the same set of inputs. Line number 41, there is an error. it says for the 36% your NPV will be 0. Let us confirm it by putting the rate of returns here. So it's say point for 36%, your NPV is 6, very close to 0. You put the next value, the NPV will become negative, because this 37 is a bit on the higher side. So for this project, 36% is the rate of returns as calculated. I hope you all liked the video. So put your comments and see you. Bye until the next video.